Assalamu alaikum. This is first example, series parallel example, after we have covered KCL and KVL. To solve this problem, I will start by identifying nodes and how many nodes in this circuit. Change the color, so this is red. Maybe I will enlarge the picture too. Node number 1, 2, this is 1, 2, and this is 3. All of them are 3. So 3 nodes. Is the circuit series? There are nodes with more than 2 elements, so no way it is series. Is it parallel? Nope. It is not parallel, it is more than 2 nodes. So this circuit is series parallel. After that, this kind of circuit, you have to look at the gift given to you. First, maybe the first thing you think about is finding R total. And then after you find R total, you say, what I'm going to do after that? My advice to you, whenever anything given to you in the question, here is the VR2, voltage across resistor 2, use that one. Start by using that one. This indicates the voltage across R2 is 360, so we can use that with the knowledge of Ohm's law, V equal IR. So we have both of them, divide voltage by current, and you got the current of 4 amp. So 4 amp in this branch. What else can I choose? Using the background information, we introduce it before we study or we look in details about KVL. I will start to use this and label, this is the conventional current, so this is positive, negative. As the current will move in this direction and in that direction, and this is positive, negative, and this is positive, negative. We have one loop, this is another loop, and we have the outer loop. Loop number 3. If you notice, R2 across node 2 and 3. R3 between node 2 and 3 too. So R2 is in parallel with R3. Since they are parallel, they have the same voltage. This is the definition of parallel. When elements are in parallel, they have the same property as the parallel circuit. An equivalent resistance of these two is as the equivalent resistance in a parallel circuit. So these two is considered as parallel circuit. So the total resistance is 1 over plus 1 over. Now, in the same time, they have the same voltage. So VR2 equals VR3. We know it is given to us VR2. So VR2 is 360. So VR3 is 362. Now, VR3, and both of them is 360. VR3 is 360. and at the same time it is IR. I know I, but I don't know how much is R. And here IR3. So IR3 equals 360 divided by the current 60, which is equal to 6 amp. So this current is, sorry, it will be in this direction, coming to this direction, 6 amp. And the current coming to that direction is 4 amp. Now I will apply, sure the current in this direction is total current. So I total applying KCL at this node, which is node number 3, at node 3, I total equals 4 amp plus 2 amp, which is equal to 10 amp. We know the voltage. Let me copy this. I just need to copy this circuit and paste it here. $360, $360, and current here is 10 amp. So this R1 equals to 10 times 10, 100 volt. Now KVL, I will apply KVL in loop. I call this loop 2. So apply KVL around loop 2. What we get from the current direction, this is positive, this is negative from this circuit, and this is positive, negative. So the first thing we see here is minus VR1, and then we have plus VS minus VR3 equals 0. So VS equals VR3 plus VR1, which is equal to 100 plus 360 volt, or it is 460 volt. Thank you.